Finish off 2.1, starting on number 7 here. So Teresa is on a road trip, keeping track of her fuel consumption. Okay, the graph below shows the amount of gas in Teresa's car at different times of the day. Use the graph to discuss what she may have been doing during the different time frames. Okay, so just to reiterate the things we talked about yesterday, what do we always put on the x-axis? Time. And then the responding variable, whatever it is going to go on the y-axis, okay? Okay. So this is volume of a gas tank with respect to time. So obviously if you're driving, the volume of your gas is going to go down. And then if the volume is rising, what must she be doing?
Filling it up.
Filling the gas tank up. Okay, so this is a positive or a negative slope? Positive, so you will be gaining in the y. Okay? Got a light slip? Go get a light slip. Okay, negative slope. Why did that just happen? Negative slope, she's going to be losing gas. And then what about a zero slope? What's that going to be? No change, so it'll be parked. Okay, so let's look for these. And we'll do it together. This part, she's driving. Is she driving fast? You don't know? What about if you compare it to this part? Like, look at the pointer. See, from here to here, the slope is steeper than from here to here. So she's driving faster. She's using the fuel faster. This part here where it's flat, she's parked. She's not driving. Okay? She turned the car off or something. Why did she turn the car off? Maybe she grabbed lunch. Who knows? And then from here to here, she's filling up her gas at the gas station. Then she's driving. Then she's parked. Then she's driving, parked. That make sense? Okay. So you can just jot some of that stuff in. Next one, lumber. Priced in board feet. A board foot is a piece of lumber 1 foot long by 1 foot wide by 1 inch thick. The graph below represents the cost per board foot of this over a period of 1 year. So what is the general trend? What is the general trend? What do they mean, general trend? You're looking for a pattern. Okay, so what is the pattern in cost? Cost is on the y-axis, so you're going to see if it goes up, down, or stays the same. In March, how much is it worth? $3.50. And in February, what's it worth? Just over 300, maybe like 320 or something. It went down, it went up, it went down, it went back up. So what's the general trend? It goes up and down, but relatively the same price. Like it went down a little bit. So these types of questions, okay, if it's a written response and you write if you write a statement that makes sense with respect to the graph, I'll give you the mark. Okay, if it makes no sense at all with respect to the graph, I won't give you the mark. I'm assuming the multiple choice will be more straightforward than something like what is the general trend. The graph does not show the cost in August. Okay, so now we're doing B. Use the graph to interpolate. So interpolate means inside. Okay, so looking inside. Where's August? August is here. So we got to find where August would be on the line. Looks like right here. I'll highlight it in pink. So it's between 300 and 350, right? So what is it? 330 or 325? Okay. I'll use one of these, 330. That little squiggle just means I'm guessing. It's approximate. that little squiggle. Based on the general pattern, what would you estimate the cost of the wood to be the following month on March? So what is this called? Not interpolate, but extrapolate. So we got to go to March. What's happening in March? If it follows the trend, it probably goes up a bit. So roughly 350. I just like went up a bit following the trend. Goes up, down, up, down, up. And these are all going to be different answers depending on what you think is going to happen. So extrapolation on a random graph like that doesn't really have much merit to it. Okay? So let's just keep going. See if we can find some more valuable questions. Example 4 is done for you. They're showing you, looks like a double line graph. So how do we know it's a double line graph other than the fact that the solution's already written for us down at the bottom? What you see here, this time, this is, what is always time? The x. And then here you have 2 more rows, so it's like y1 and y2. That's how you know it's a double line graph. So like Regina has some information, Vancouver has some information, and you're going to graph both of them. So that's why it says, when it says display the info, they have 2 graphs showing that information. They give you a legend to help you figure out which one is which. They're using like a dark line and a gray line. Okay? So dark line is Vancouver, gray line is Regina. And then part B, it says, what conclusions can you draw from the table about house prices in the 2 cities? They went up, but they stayed relatively the same. Do you agree with that? And also, Vancouver, it's more expensive than Regina. Clearly, it's much more expensive. And what can you tell from the graph more readily than from the table? What do they say? The prices in Regina increase more rapidly than in Vancouver from 06 to 08. After 2008, the prices increased more rapidly in Vancouver. Okay, so making conclusions, what you can tell from the graph, I mean, it's always going to be different, but it's flat in this section, and it's increasing in this section. And then after 2008, it's increasing up here, but staying flat there. So different things are going on in the 2 different cities. All right. So let's build one of these double line graphs. So make sure you got your ID card or something, or your debit card, and you need to give yourself a grid. Okay, give yourself a grid. Now we need to label our graph. So Mustafa, you gotta peel the headphone out. What do we put in the x-axis? Month, because it's time. And what do we put in the y-axis? What are we even talking about? Number of cell phones sold. Okay, so number of I'm just gonna put cells sold. Okay, now we need to think of some sort of scale. What's the smallest number? What's the biggest number of cell phones sold? 21 is small. What's the big? 398. So basically we got to go from like 0 to 400. Okay? So let's chop this y-axis into sections. Obviously 0 is your start point. Let's do 4 sections. 1, 2, 3, 4. 100, 200, 300, 400. And then what do you put for the x-axis? How many ticks? We're doing months, so you need 12. So just maybe use your pinky or something, but just you can eye it out every 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, January, February, March, April, May, June, July, August, September, October, November, December. And then I would just estimate these points. Like 53. I mean, do I care that it's perfect? I just get some semblance of it. The next one's 150. March 75. And you keep going in this fashion. And then for female, you know, maybe when I'm first doing this, I'll just draw circles instead of dots. So female 222. I'll use dots instead of circles. Maybe you have a different color pen. Okay. March. I was going to do one at a time because it's getting confusing. So just do the boys first. April 240. May 105. And so on. And then when you connect them, all you do is just draw straight lines from each point. This is called a line graph. It just gives you a visual on the behavior of the data. Okay, does it bounce up and down? Does it stay the same? And again, does not have to be perfect. But you should have labels, so I know what you're talking about. You should have an appropriate scale. The only thing I'm not worried about is like if it's 50 or 53, like I don't really care. Especially when you're talking about these big numbers. So is this point here 50 or 53? I don't really care. I just want to see just the general behavior of the data. So now I'll do the girls. Oh, there's a 442. That's the bigger. And if I have another color pen, I'll use it now.
Yo, you teach right now?
Mm-hmm.
Oh, sorry, buddy. Where's Cliff Mohammed? Cliff, where are you?
Right back here.
Okay. Where'd the caliper bolt go for that car you're working on today? It's missing one. I can't put it back together. You have an extra bolt in your pocket at all? No? You sure?
Cleve, step out for a bit and help out Mr. Shaw.
You don't want CJ or anybody else in there? Alright. Sorry, buddy.
No worries. This is some basic stuff.
You have no idea where that bolt was? Does CJ have it or anything like that? 'Cause there was 4. She can only find 3 right now.
Okay, and then like once you have all this done, I know this isn't fun and it ain't pretty, and you might think it's dumb or whatever, but you just got to kind of go through the motions, get it done. And what the picture does better than the table is allow you to compare, okay, visually. You know, if you just give the chart in the newspaper or something to people, they're never going to read it. If you ever go into advertising or anything like this, you're going to learn that people are all visual. People are all visual. They want to see stuff. If they don't see it, they're not going to care. Like, think about how long you spend on a web page before you click away to the next web page. How often do you think you're on a web page for before you click a link to the next one? Like 3 or 4 seconds before you're on to the next page? So think about what the advertisers are trying to do. They're trying to get your attention in a few seconds. How are they going to do that? It's going to be visually through a graph. All right? So once you have this done, you can start to answer these questions. Write a statement describing the general trend. So what's the pattern in the cell phone purchases over the year? Does it stay the same or does it fluctuate? It fluctuates. You guys know what that word means? Fluctuates. It goes up and down. And just like anything other than like, yeah, I think this goes pretty much anything other than like gas or the main essentials. Anything you sell, there's going to be peaks and valleys. Like, okay, what are the big peaks? Where are they having the most cell phone sales? August, September, and December, right? So think about why the peaks might be August, September, and December. Christmas for sure, and back to school. Good. So those are the kind of like assumptions or generalizations that, or inferences that you got to make, okay? So let's see what this book wants us to do. Indicate any relationship between the number of cell phones purchased by males compared to females. Does it pretty much follow the same thing, males, females? Males and females, pretty much the same. Follows a similar trend. That's what I would say. Male and female follow similar trend. Do you think this graph is useful? And like, don't be like a jerk about it. Like, no, I don't care about this. But actually think, is this useful? Well, if I was in the marketing industry, what would I want to do from this graph? I would want to make sure I'm pumping my best product in September and December, right? Or maybe I'd jack the prices up a bit in September and December because I know they're going to be buying phones. So is it useful? You know, it might help in sales. Might help in sales or even advertising. Like, when's the best time for us to put on a commercial for our product? Okay. What might be a better way to show trends in cell phone purchases? What might be a better way? Yeah, type. But I think they're telling them maybe use a different type of graph. Maybe a bar graph would be better. Yeah, I think type would be a good way to do it. Like compare iPhones to Androids or stuff like that. So not a big deal there. The most important thing there is just, can you build a double line graph and understand what's happening? Okay, so number 10 is identical. So maybe we'll just skip 10. It's identical. All right, new skills, working with misleading graphs. Okay, so it says the scale and size of a graph can influence the way you interpret the data. By changing the scale on an axis, okay, so underline that, by changing the scale on an axis or changing the starting point of an axis, you can change how a viewer interprets the graph. While the graph will still be right, you can influence perception. What's perception? That's how people view things. Okay? So for example, if my boss walked in here and saw all you guys on your cell phones doing nothing, what would he think of me? Okay, so his perception of me is important, right? And perception sometimes is sometimes more important than reality. Because like I said, when people are seeing things, like how quick do you make a judgment about somebody? Think about first impressions. If you walk into class, I got, maybe I have cut off jeans up to my upper thighs. You gonna think I'm a professional? No, so perception is important. You got a question? Yeah, people people will judge you in a split second. So this is what they're doing in graphs. So like, if you've ever watched like Fox News, these guys are the usual suspect for this kind of thing. They put up like misleading graphs and like, oh yeah, blah blah blah, guns this, terrorism that, and it's propaganda, right? They'll try to trick the people into thinking a certain way so that the political landscape will change. Okay, so Fox News, the media, can be culpable for this. Okay, so it's important for us to understand what's happening. Okay, so example 5. The graph below indicates the approximate cost of metal per ton over a period of time. So what does it appear has happened to the price of metal over time? Looks like a sharp decrease and a sharp increase, back and forth. Let's just see what the answer says. The graph seems to show that there is a lot of fluctuation, okay? A lot of fluctuation in the price over time. Now let's take a look at the axis. So it skips from 0 to 500. You see that? See that little squiggle? So you miss all of those, and then it blows it up. So from 550 to like 750 basically, there's like 1, 2, 3, 4, 5, 6, 7, 8 different scale ticks or whatever you want to call them. Okay, so if you change the axis, you change the scale, okay, they include the 0, they include all this stuff like this. Does it look as sharp, or does it look like it's relatively staying the same? Yeah, staying the same. Okay, so that's misleading graphs, checking the scale. What does the new graph show about the fluctuation in price? The new graph don't look as large. The fluctuations don't look as large, okay? And yeah, Fox News is ridiculous for this. You could Google this if you want. Misleading graphs from Fox News. And they'll have like, it's kind of funny, like, I don't know if I can draw it, but they'll do bar graphs where like, they'll chop off. So here's all these bar graphs, like, maybe they're like this. They'll chop all the bottom half off, and they'll be like, oh, look at the sharp increase. But it might be like a 1% increase. But when you chop all the rest of it off, it looks like a huge increase. So whatever. It's just the way that the media will try to shift your opinion. Okay, keeping going. Here we go. Let's finish off this section. 11, 12. Yeah, 2 more questions, and then I'll let you guys do the daily quiz, and then I'll let you finish the homework. Okay? And then that'll be that for today. All right, so consider the graph below. What are all the main features of a graph? Starting from the top. Yell it out, please. What's this? Title. Now the axes also have titles. Where are they? Yell it out. Amount spent and week. You make sure you have those. Those are free marks, people. Okay? Do not be lazy. And then the other thing is the scale. So you need some appropriate scale for the weeks and the y-axis, or the x-axis and the y-axis, whatever it is. Okay, so when it says what does it represent, you put verse in the middle, and what goes first, y or x? Yeah, x goes first in the ordered pair, but when you talk about what does it represent, it's always y versus x. So in this case, what is y and what is x? Amount spent, so it's basically dollars versus week. And then look at the title. We're doing groceries. So do you know where to look for when it says what does it represent? Y versus x. How does the responding variable respond to the x-axis, and the context is in the title? Okay, easy breezy. So what is the general trend in her grocery spending? Increase, decrease, or stay the same? And I'll put all these here, and then we'll circle it, so you know what your options are. So you're not going, what do I know what to put? In this case, it's increase, not decrease, and not stay the same. And what is misleading about the graph? It's this little squiggle here. Okay, so they omit first $20. And draw a graph that better represents her expenditures. We can draw graphs later. So skip. Because you're going to get practice doing graphs in a second here. And all that would happen is because like what's misleading about this graph is this sharp increase. If you think about it, does this look like a huge increase? Like look at this, look at the slope. It's like, that's pretty steep. You want to go skiing on that hill? Yeah, it's steep, right? So it looks like a huge increase, but then think about it. It went from $20 to $24. Is that a really big increase? No, it's because of the scale going up by 50 cents and the fact that they skipped the first $20. See the difference between perception and reality? And this is something that I didn't really learn about in life until I was really a lot older, okay? So perception is important, even though you might think it's not. Okay, like when I was growing up playing hockey, say I got in trouble at school, or maybe I was hanging out with the wrong kids, okay, like the people that were watching me, the coaches, whatever, they're making judgments about me, and they're going to decide my future. Okay, oh, he hangs out with the wrong crowd, maybe you don't want to pick him on your team. Okay, this is like a hypothetical situation about life, but perception is important, okay? Okay, I don't want to like lecture you guys about life, but we're doing graphs and it's kind of boring and they're talking about perception, so I just want to connect it to real life a bit. So consider the next two graphs that show the percentage of population of Alberta living in rural areas. Rural. All right, so look at the dates, 1901 to 2001, 1901 to 2001. Look at the titles. Percentage of Alberta population, percentage of Alberta population. So it's the same. Everything's the same, except for what? Look at the scale on the years. Is the scale on the percentage the same? 0 to 80 and it's going up by tens? 0 to 80 and it's going up by tens. You guys see that? But then look at the years. Going up by 20s. And then this one's going up by tens. Okay? So on the first graph, it looks like a sharp decrease, and in the second graph, it looks like a more gradual decrease. Okay? So that's what they're trying to get after. Which graph makes it appear that the decrease in rural population was more rapid? It happened faster. The first graph. Which graph do you think is a better representation of the actual change in rural population? Who's doing that? Josh, the door's right here, bud. Okay, well, quit it, whoever it is. Okay, so the second graph, you guys think? I think it's the second graph. Because it gives a more, it doesn't skip a whole bunch of years at once. How can you skip 20 years in one tick? Like 20 years of time in one tick. Like, it's kind of crazy. Anyways, use the graphs to interpolate what percent of the population was rural in 1916. Okay, so where's 1916 going to show up in our graphs? It's going to be easier to do on the second graph. Probably like somewhere halfway on the 1911 and 1921. So it's between 60 and 70. Let me blow that up. I'm thinking like 62% or something. You guys agree with me? Okay, so 62% from the second graph. In what year was the population half rural, half urban? Okay, so what are you talking about half and half? What percentage is that? 50%. So now we have to look on which axis, the time or the percent? Percent. So you're going to look on the y-axis this time and then draw a cross. So where's 50% on this graph? Right here. Blowing it up. So now when you're doing this, you got to go across from 50 and then find out when it hits. Find out when it hits and now draw down, and it looks like 1951. Okay, so sometimes they'll give you the time. So sometimes they'll be down here and then you have to go up and over to find it. Or sometimes they give you the y and you got to go over and down to find the time. Okay? Use the graph to extrapolate what percent of the population will be rural in 2011. Okay, so 2011 is going to be the next tick. 2011. So it's going to probably do something like this. I'm thinking this is like just under 20%. Around 18? Sure. 18% in 2011. Alright, so what we'll do is we'll work on the homework. So finish the section. Finish the section off, 2.1, and then probably in about 15 minutes I'll hand out the quiz, and then we'll mark the quizzes. Pardon me? Do you want me to blow that up a bit? Better? Second graph, first graph, second graph, 62%, 50% y-axis.